Alright guys, this is unit number 9, lesson 4. Today we're going to be solving quadratics by inverse operation. And really what we mean is we're going to be solving quadratics that can't be factored easily. And remember, inverse operations is how you'd easily solve something like this equation here. Remember, we'd do the inverse and we'd subtract 1 and minus 1, and then you would have 2x equals 6, and then you divide by 2 because that's the inverse of multiplying by 2. So that's what we mean by inverse operations, the way you normally solve an equation. So now that you have a good feeling about square roots, we can use them to help us solve some special types of quadratics. And there we go. Here we go. So we'll just start. These first ones are kind of easy. Now you could solve these by factoring. You could set them equal to 0 like you normally do, and then this would turn into a difference of two squares and you could factor it. However, in these situations you can't use inverse operations, because if I want to get x alone, I could just take the square root of x squared, and that, there we go, and that would just be x. But whatever I do on one side, I must do on the other side, so then I could take the square root of 16, which we could do in this situation. So, and you should write this down. So the way we got this is we did the square root of x squared. Sorry, my pen's not working great right now. And then we did the square root of 16. And then the square root is the opposite of the square, cancels out, and you just get the x. Now, when you take the square root of 16, you get plus or minus 4. We don't really need this plus or minus here. But you got to understand that the square root of 16 is negative 4 and positive 4. So we want you to start saying plus or minus 4 now. Don't just tell me the square root of 16 is 4. The proper way to write that square root of 16 is plus or minus 4, like that. So we have to start doing it like that when we solve it. So therefore the answers to this is negative 4, positive 4. We can plug that in and it works. So we can easily do this the same way. Take the square root of this side, take the square root of that side, and you're going to be left with x equals the square root of 100, which is positive or negative 10. Again, we don't really need this here. Oops, I'm trying to get rid of. Let's not put it there. Just really, it should say x equals the square root of 100, which comes out to be this. And here x squared equals. Now this time, when we do this, however, we take the square root of x squared and get x. You take the square root of 20, and that's not a perfect square. So simplest radical form, you should know how to simplify that. So why don't you do that now? What is square root of 20 simplified? So hit pause and try that. Okay. And then hopefully you know that square root of 20 is square root of 4 times square root of 5, and now I can take the square root of 4, and again we should be writing plus or minus 2 radical 5. So the key here is the inverse operations to squaring is square root. So if I want to get rid of the squared, we do the square root. But then you do this always to introduce both the positive and negative answers. That's important, because this is a quadratic equation. And remember, therefore, it's like a parabola and probably has two solutions. The squaring is a non-reversible process, meaning that you can't simply undo it. So it's not an easy thing to undo. Now let's add some additional operations. Recall that we always solve equations by undoing operations in opposite order in which they've been done. So in terms of order of operations, exponents essentially come first, so now we would undo those last. So remember, we taught you to solve equations by doing reverse order of operations, and that will help out in this. So solve the equations for all values of x in inverse operations in each of these cases. Now normally what you'd do, since this is a quadratic, you'd set it equal to 0 by probably subtracting the 28 over there. We want you to try to get this x squared alone now, and therefore if the x squared is alone, it's just like one of these problems. So I'll help you with the first one, and then hopefully you can do some of the rest. So solve this like you normally would with x. We're going to get x alone, so reversed operations, well first you would multiply and then you would add 10 to do the opposite, subtract 10, divide by 2. So that's what we're going to do here. We're going to subtract the 10 just like you normally would. And then you're left with here. And now I'm going to get the x squared alone, so I divide by 2. And now I have x squared equals 9. And see, that's easy to do now. Again, you could have done it by the old way of subtracting and then factoring, and you get the same answer, but later on we won't be able to factor some of these. And now the square root of 9 is positive negative 3. And you could write your solution this way also. So x is positive negative 3. That's the solution set. Now you should be able to do part B on your own. So hit pause and give that a try now, please. Okay, so again, notice there is no b term in this quadratic where it's ax squared plus bx. If you notice there's just an a term, then that's when we could do this way with just getting the x squared alone. So when you did that, we want to obviously get rid of the negative 5, so add 5. Then to get rid of that 2, remember that's dividing by 2, so you'd multiply by reciprocal or multiply by 2. And now we have x squared equals 16, and the square root of 16 is plus or minus 4. And there are your roots, or solutions. Okay, hit pause if you need to. All right, again, how about I help you with C, and then I see if you could do D. That's the hard one here, and if you could do D, you'll be good to go. So if you look at C, we need to get this x alone. Now you have to be very careful, and I want you to think about if I gave you this order of operations, what would we have to do? Well, you would subtract this first and then square, because we do parentheses first. So remember, we're going to do everything in reverse order of operations. You cannot add this 2 to get rid of it on both sides, because this 2 is trapped in these parentheses. So you have to get rid of those parentheses before we can do something with that 2. So hopefully that really makes sense. So what you can do is you could take the square root of this whole thing, since you're squaring this whole thing. Therefore, this square root would cancel that square root, but then you'd have to square root this side also. Same concept as doing before. Oops, sorry. There we go. So let's see how it looks in here. So that's what they did to get this part. So hopefully you understand. Kind of skipped over, but this is the square root of this. So they took the square root of that, and that's where this part came from. Now, you could actually take the square root of 25, which would be plus or minus 5. Now remember, this counts as a positive 5 and a negative 5, so that would make 2 equations right here. So this would be the first one, negative 5, and this would be the second one. So that's what this means, positive or negative 5. Now look, that's a really easy equation to solve. You just add 2 to both sides, add 2 to both sides, and again, we're getting 2 different roots. All right, now, also if you notice part D here, what form is this in? I hope you notice that that is in vertex form, which would help us solve some problems. Whoops, I wish I had done that. But go ahead and hit pause and see if you could actually solve this one like we did over here. Now this one's a little more difficult, but we'll see how you do. So hit pause and give it a try at least. Okay, so on this one, again, you can't deal with the square root stuff until you get it alone like it is over here. So we have to get rid of this 2 and this negative 50. So just like before, we're going to do reverse operations. Get this minus 50 would be the last thing. Think of order of operations. You would add, then you would square, then you'd multiply, and then you'd subtract. So we're going to reverse it and do the adding first. Then I want to get rid of this 2, so that means I need to divide by 2. And that would leave this here. And now that I got here, I can take the square root of this and the square root of that. And then remember, when you take the square root, I don't like that they're kind of skipping that visual. I think it's good to see that you guys are doing this. And that leaves the square root of 100, which is plus or minus 10. So now you have this x plus 5 equals positive negative 10. So that makes 2 different ones here. And then you could just solve them. So if you got those on your own, nice job. If this was confusing, ask in class and I'll help you out. All right, so let's keep going here. Always hit pause and rewind if you need to. Okay, of course, there is no reason our answers must come out to be rational numbers, as in exercise 3. You can also have answers of these types that involve irrational numbers, and that's why you would do it. In these cases, they're typically asked for some unknown reason to express in simplest radical form. So you might be solving a quadratic that can't be factored, and that's when we can start using these different forms to help us out. So let's take a look at this one. As you can see, there's no b term. There's no like just plain x. So then let's work on just getting the x squared alone. So no different than what you just learned, so I won't waste your time. You're just going to add the 2. Then you're going to divide by 5. And then you're left with x squared equals 8. I'm going to pause it here and see if you could do the rest on your own. So could you get the solution to that? So hit pause and give that a try. All right. Basically, remember, you're going to take the square root of x squared and the square root of 8. However, hopefully you realize square root of 8 is not a perfect square. So you'd have to reduce that down to radical 4 radical 2, which turns into this. Now this is positive 2 times radical 2 and negative 2 times radical 2. So there are two solutions right there. Alright, so with that done, hopefully you should be able to do B, express answer in simplest radical form if it is not a rational answer. Alright, so with this problem, again, let's get, so they skipped a step, but you can see what they did. They subtracted 10 to both sides. That's how we got here. Hopefully that makes sense. Now I have to take the square root of this, so I need to take the square root of that. And taking the square root of this gets rid of the squared, so hopefully you understand that's where this is coming from. Now that is not a perfect square, so let's reduce it down to radical 4 radical 7, which turns into this. Now notice there's an x minus 3 here, so this is not our solution. X minus 3 equals this whole thing. So now we have to say something like this. X minus 3 equals the negative form. X minus 3 equals the positive form. And now I'm going to add 3 to both sides. Now look, these are unlike terms. Imagine this is more like, whoops, my pen went away there, negative 2x. So I want you to think of this as kind of that. And if I try to add 3 to that, you should know we can't add those, because I have to multiply this thing before I could add things. Same thing here. I have to multiply 2 times 7 before I could add something. So that's why we call these unlike terms, and you cannot add these together. So simply see how we write it is 3 minus 2 radical 7. Same thing over here. So you can't add a rational and irrational number when it's in radical form like this. Just leave it like that. So there's your solutions. Okay. So I got to speed things up, so just hopefully you'll be able to stay along. So here we had this graph. They graphed it. It makes sense because, see, we went down 6. We multiplied it by the half, so we compressed it, making it wider. And Francis, I guess, said the zeros are negative 3, positive, or negative 3.5, positive 3.5, because that's where they looked about right there. There's your zeros. Now, why don't you go ahead and try to solve this like we just learned how to and put it in simplest radical form. So hit pause and try to solve this and come up with the zeros algebraically, we'd call it. Alright, when you did that, we want to obviously set it equal to 0. Then get the x squared alone, so add the 6's to both sides. Now get rid of the half by multiplying by 2, and you end up with this. Then I take the square root, and I get square root of 12, which becomes radical 4 radical 3, or 2 radical 3. Now, he said 3.5, but hopefully you realize that this is an irrational number, and this is a rational number, so his guess is not correct. So I'm going to erase this. Francis can't be correct because the zeros are irrational numbers, yet his choice were rationals here. So these were the correct zeros. Francis was incorrect, but by how far off? So you should be able to tell me the decimal approximation of this. So go ahead in your calculator and find out what this would equal. So hit pause and do that. And when you put that in your calculator, you should have got 3.4641 and so on. So that was really close to his guess of 3.5. So he was close, just a little bit off. All right, hit pause if you need to write that stuff in. All right, I guess I'm doing okay because we're on our last example here. So we can slow things down a little. Find the zeros of this. Now, hopefully you realize, again, this is in vertex form. So we can see it went down 20 and to the left 4. But this will help us out because when we can't factor a quadratic, we could put it in vertex form and then just solve it like we know. So hit pause. Notice it says round answer to the nearest hundredth. So therefore, you don't have to put simplified radical. Hit pause and give that a try. Oh, and hopefully you read the directions better than I did. It says put it in simplest radical form first and then the decimal form. So I apologize about that. Alright, so you just have to set this equal to 0. Put this side. Now we have to get the x squared, or the whole thing squared alone. So add 20 to both sides. And therefore we have this now equals 20. Now I'm going to get rid of that squared by square rooting the entire thing here. That would leave that alone. I have to square root 20. There we go. Which turns into that. Which turns into this. Now we'd have to remember, this is two equations, a positive and a negative. So we have this one and this one. Solve it like you know how to. And this is simplest radical form. Remember, you can't actually add or subtract this stuff. Oops.